Okay, let's take a few minutes and talk about forces on inclined planes. So before I actually start talking about a force on an inclined plane, let me talk about something we already know about, which is a force that is applied on a flat surface. When you have a force that's on a flat surface, you know that there is a force of gravity pulling down on it. And you also know that there's a normal force from the surface pushing back up on the box, and those forces are going to be equal and opposite. And we call this force up here the normal force. Now, according to Newton's third law, the force of gravity is going to be equal and opposite to the normal force because forces always come in pairs. And also, according to Newton's second law, if there is no acceleration on the object, that means there's no unbalanced forces. So because this box is not going to be accelerating, it's just sitting in one spot, there's no unbalanced forces. So we can say that the force of gravity is equal to the normal force. Now, let's use that and move on to forces on inclined planes. Now, whenever you put something on an inclined plane, it changes the dynamics of how the forces work. It doesn't work the same as this anymore. But there are still concepts from here that do carry on to over here. First off, the force of gravity is still straight downwards, just like it was on a flat surface. Another concept that carries over from here to here is that the normal force is perpendicular to the surface. Now, it's not equal and opposite anymore, but it is still perpendicular. Now, whenever we are over here and we have the force of gravity pulling down on the object and the normal force pushing against the object, pushing it back up, at this point, the normal force is actually smaller than the force of gravity. And these two forces are no longer equal and opposite, and these two forces no longer balance each other out. Now, you may ask the question, well, if they're no longer the same, then over here, how do I now find the normal force? Well, let's talk about that. Alright, so first off, let's go ahead and draw some of the forces that we know about. We know that there's a force of gravity pulling down on the object. We also know that there's a normal force pushing perpendicular to the surface on the same object. Alright, so the first thing you need to do is set up a coordinate system on this plane. Now, since this plane is not flat, you're going to have to tilt your coordinate system to match this angle right here. The x going down the plane and the y being perpendicular to the plane, like so. So we switched up the typical coordinate system for this problem. And this is actually going to end up being very helpful. The next thing you're going to want to do is break up this force of gravity into its components. So we need to break it up into its y component and its x component. Now we've broken this FG into its y component here and its x component here. So we can call this side over here FGY. And this FGY is going to be equal and opposite to this normal force up here. So this component of this vector tells us the normal force. And one more thing we need to know in order to solve for the normal force is the angle at which the surface is at. So angle according to the horizontal. So if I were to draw this, and we call this angle here theta, this angle here is actually the same angle up here between these two, because FGY is adjacent to the angle, and we also will know the force of gravity. We can use cosine to find FGY. Now, one thing I haven't addressed yet on this is what if there's friction on this inclined plane? And that's what we're going to talk about next. Now we know that friction opposes the motion of an object. So on an inclined plane, we need to think of two different situations: when the block is not accelerating and also when the block is accelerating. So let's first look at when the block is not accelerating. So let's draw all the forces that we know act on the object. First off, we know that there's a force of gravity pulling straight down. We also know that there's a normal force that's perpendicular to the surface. And we also know that the block wants to slide down the plane, but friction is fighting against it, pushing it back up. And if the block is not accelerating, all these forces right here are going to be balanced. So that means that there is no net force. It might be moving at a constant velocity, or it might just be sitting there. Either cases, it is not accelerating, so therefore all these forces should be zero. And if all the forces are zero, that means that there's no net force. And now we need to figure out how to actually solve for the force of friction. Now, to solve for the force of friction, we need to break up the force of gravity into its components once again. So let's do that. Now, since all the forces are going to be balanced, we know the normal force and this FGY right here are going to be equal and opposite, and they cancel each other out. And if there's no acceleration, this force pulling down the ramp right here needs to be equal and opposite. So these two right here need to be equal and opposite. And since we've switched up our coordinate system to where going down the ramp is now the x direction, this would end up being called F of gravity x, FGX, force of gravity in the x direction. And the force of friction and the force of gravity in the x direction need to be equal and opposite for there to be no acceleration. So therefore, if the block is not accelerating, force of friction and force of gravity in the x direction are equal and opposite. Well, how do you find FGX then? Well, once again, you need the angle of the ramp. And that angle is the same as this angle inside of here. And if we know this angle, and this FGX is opposite to the angle, that means we need to use our sine function. So to find FGX, we need to use sine and the force of gravity, because the force of gravity is the hypotenuse of this triangle here, and FGX is opposite to it. So if we use SOHCAHTOA, sine is opposite to it. And with just a little algebra, you'll find this. So if you needed to find the force of friction and the block is not accelerating, you would just need to find the FGX, the force of gravity in the x direction. And you could do that by taking the force of gravity, multiplying by the cosine of the angle. Now, what if the block is accelerating? Well, if this block up here happens to be accelerating, that means that the forces are unbalanced. According to Newton's second law, if an object is accelerating, then there's an unbalanced force going on. So, with that said, we can say the sum of all the forces is not going to be equal to 0. So there is going to be some unbalanced force. And we know that the normal force and this FGY, this force that's opposite to it, we know that those two are going to be equal and opposite. So that means that the only forces that would be unbalanced would be this FGX and this F of F, the force of friction. And if it's accelerating down the ramp, that means that the FGX, the force of gravity in the x direction, is going to be greater than the force of friction. So let's take this information and go solve some problems.